Welcome to the Ashdale Regiment. Today we're gonna have a simplified look into how our position is as a species residing in the inner solar system, with the intent of providing a short-handed perspective you may be unfamiliar with. Here is a planet, and here are two fundamental factors we can currently manipulate in order to control the temperature of a planet. One is altering the atmospheric composition, by either adding or removing radiatively active gases that absorb the radiant energy emitted by the planet's nearby star, meaning that any planet with an atmosphere can have its temperature tweaked using these gases. A second, perhaps less known method is directly shielding a planet from a star's radiation, which can make for quick results. Or inverting the approach to reflect more radiation onto the planet, which would otherwise have bypassed it. This particular planet has a very thick atmosphere and is close to its star, which makes it easier to effect these changes. The planet being shown here has an atmosphere as well, so we can adjust its temperature via its composition. This is of course good news, because it happens to be a planet which we already inhabit, so we don't have to travel far in order to research terraforming in that regard. Given that the current focus is mostly directed at another planet, namely Mars, which barely has an atmosphere or solar radiation to play with, rather than making a significant space infrastructure near Earth, it's simply not going to be cost effective enough for us to realistically implement shades and reflectors anytime soon. But for the sake of argument, let's suppose we had an orbital and lunar industry that was already in place, so the prospect for shades and reflectors became more tenable, or even easy to apply. Using this planet as an example, we could increase the amount of CO2 and retain a stable temperature by adding solar shades. For many planets, this is good enough, at least for a start, but when the planet has oceans with life forms, this particular gas will absorb into the water and cause it to become acidic, threatening the collapse of the marine biosphere. To any wannabe spacefaring species who would like to have a marine biosphere on the planet, this warrants particular attention. Historically speaking, when marine biospheres have collapsed, it's generally unpleasant to be a terrestrial being as well, so it's nice to have it regardless. Of course, if our industry is already this well established, we could convert our shades to absorb the radiation, to power our burgeoning infrastructure, and for that matter beam down the energy to Earth for direct use. The amount of energy hitting the atmosphere remains much the same, but our energy supply would no longer have the byproducts currently affecting the atmospheric composition. Indeed, with as much energy available, we could with relative ease use some of that energy to sequester the gases we do emit, as well as what has been accumulated from earlier times. Entertaining the expansion of this infrastructure further, we could, as mentioned earlier, also utilize the radiation that would otherwise bypass the planet to power an expansive space industry. And orbital shipyards will of course be absolutely necessary to construct any spacecraft of sufficient size to create artificial gravity, but it's probably repurposed power satellites that will propel our vessels around the inner solar system using sails. It stands to reason that what is undisputably the most abundant and readily available power source in the entire solar system would be our first objective, and that is of course the Sun. Less than 99.9% of this energy hits our planet, but once we're situated near the Sun, we can implement the same approach deliberated so far, to a truly breathtaking scale. With this amount of energy, we do not only have most of the solar system well within our grasp, but we could, even with our current fusion technology, transmute the hydrogen from the Sun to create heavier elements, even radioactive elements, as fuel. where beaming solar cells are problematic. This would be enabling us to travel beyond our own solar system. Going back to Mars for a minute, the oft-mentioned issue of needing nuclear energy to sustain a decent colony there becomes moot, especially since we now can increase the amount of solar radiation reaching the planet, and could conceivably create an artificial magnetic dipole to protect the feeble, nearly non-existent atmosphere on Mars. While limited gravity will still be an issue, it is first at this point. We are now talking about meaningful expeditions, rather than clawing for vacuous prestige. But then again, these toys are still just on display. We know they're there, but mommy won't yield before we clean our room. Don't you worry, kids, there's plenty of toys in our sandbox. Since this is a life-bearing planet, there's already a powerful tool in place for tweaking the atmosphere, and that is, as many of you might have expected, life itself. In some ways, we can actually make the mere presence of humans invert the current paradigm. Okay, cool. We got an existential pet project, with us living in a tutorial playground of sorts. Next time, we're gonna look at some of the toys that we have within our reach, or even already within our hands. Meanwhile, leave a like and share this video with others who may also want to subscribe to the Ashdale Regiment, and thank you so much for watching.